The next chapter that we are going to cover is permutation and combination. Now this is one of the most conceptual and the most important chapter as far as IIT JEE is concerned, as it carries a lot of weightage. The first question which we have in hand has 3 parts. In the first part, we have 4 apples, 5 oranges and 6 melons, and we need to find the number of ways of making selections out of these. In the second part, there are n identical things and we need to find the number of ways of making at least one selection out of these n. And in the third part, we want to find the number of ways of making selections from alphabets. There are 4 A's, 3 B's, 1 C, D, E and F. So getting started with the first part, we have 4 apples, 5 oranges and 6 melons. Now the total number of ways of making selections out of apples are 5. That is, 1 apple can be selected, 2 apple can be selected, 3 or 4, and 5th way is the no apple can be selected. So it is 5 into 5 oranges can be selected in 6 ways. 1 orange, 2 orange, 3 orange, 4 orange, 5 orange and no orange. This is 6, and similarly the 6 melons can be selected in 7 ways. But this is not the answer, mind you. We have to subtract that one case in which no selection has been made from the apples, oranges and melons, and hence we have the total number of ways of making selections is 5 into 6 into 7 minus 1. This is 42 into 5, 210, minus 1 is 209. What most of the students commit mistake is they forget this 1. This 1 represents the number of, this 1 represents that case in which no selection has been made out of these 4 apples, 5 oranges and 6 melons, and hence the number of selections are 209. For the second part, there are n identical things. The answer will write to be 209. In the second part, there are n identical things and we need to find ways of making at least one selection. So there are n things. There will be first case that no thing is selected, that is NC0. There will be case 2 in which one thing is selected, that is NC1. There will be third case in which 2 things are selected, that is NC2, and this will go on up till NCN in which all the n things are being selected. But this is not our case because we have to make at least one selection, and hence number of ways of making at least one selection are NC1 plus NC2 plus NC3 up till NCN. We know that in any question in which we make cases, we get the answer for each case and then we add all the answers to get the final answer, and hence our answer is NC1 plus NC2 up till NCN. And from the binomial theorem we know that NC0 plus NC1 plus NC2 up till NCN is equal to 2 power n. This we can very easily get by using the formula 1 plus x power n is equal to NC0 plus NC1x plus NC2x square up till NCN x power n, and putting x equals 1. Hence NC1 up till NCN, this sum is equal to 2 power n minus NC0, that is 1, and hence this is the answer for our second part. Hence the total number of ways of making at least one selection are 2 power n minus 1. In the third part, we are given with 4 alphabets A, 3 B's, C, D, E and F, and we need to make the selections. Now A's can be selected in 5 ways: 1A, 2A's, 3A's, 4A's and no A's. Similarly, B's can be selected in 4 ways again. C's can be selected in 2 ways, either select them or not to select C. So 2 ways to select C. Similarly, D has to be selected in 2 ways again, and E and F again in 2 ways. This 2 represents the 2 ways that are either to select C or not to select C. But mind you, this is not the final answer. We have to subtract one case in which no alphabet has been selected, and hence our final answer is 5 into 4 20 into 4 80, or rather it is 16 into 20 320 minus 1 is 319. Again, most of the students commit the mistake of subtracting that one case in which no alphabet is being selected, and hence our final answers are 209 for the first case, 2 power n minus 1 for the second, and 319 for the third part, and these are our final answers.